Hi everyone. In the previous sessions, we explained and we dealt with congruent triangles. But today, we'll start to work with similar triangles. What we mean by similar triangles? What's the difference between congruent, and similar triangles? Congruent triangles are triangles with the same shape, in the same shape, and in the same size. So, but when we talk about similar, they are similar in the shape, but not necessarily in a size. So two triangles are congruent if they have exactly the same shape and size. And if the shape is identical but not the size, two triangles are similar. We say that the two triangles are in proportion. What we mean in the proportion? In the same ratio. Of course, we mean referring to or basing on the length of the sides and not on the angles, because the angles should be matched, equal. Okay, so if two triangles are similar, then they have three pairs of angles that are equal. So the angles we can't say another than equal angles. Okay, and the three pairs of matching sides are in proportion. Okay. Okay, good. What are we have four congruency tests, and also we have four tests to justify and to deduce the similarity between two given triangles. So also I can say we can base our idea and our justification on only the sides. So we have three sides. It is sufficient to verify that we have three pairs of sides which are in the same ratio. What we mean? So normally we have six, the biggest, the longest side, the shortest is 4, and the midst is 5. And also we have a longest, shortest, midst. It is easy to compare the longest with the together, the shortest together, and the midst together. How? Proportion, so ratio. So like we say 9/6. We verify that 9/6, the longest over the longest from this one. If we start with this triangle, so we complete to put the length of the sides of this triangle in the numerator and the other in the denominator. Okay, and the vice versa. 9/6 midst. Normally it is equal to 3/2. We investigate or we work to the other thing, the midst. So 7.5 over I mean PQ over the midst here at 5. So normally if we put it on the calculator, we'll obtain 3/2, 1.5. And finally the shortest 6/4, it is like also 3/2. So we have the three pairs of sides in proportion, because 9/6 equal equal to 7.5/5 equal to 6/4. So we can start with the ratio of the longest sides in the two triangles, then the shortest, then the order of the other pair of sides. Okay, this is one way and one of the test that we can use to verify the similarity of these triangles. And if we are in a particular case working with right angled triangle, so of course we should use the hypotenuse, one side, 190 degrees. So normally we have a 90 degree, of course, because we have two right angled triangle. So normally we don't have to mention the 90 degree. So it is sufficient to mention only two pairs of sides are, of course, within one of these pairs are the hypotenuses of two triangles. Okay, so in proportion, should be these two pairs of sides in proportion. So we have a 14, we have a 7. So 14 over 7 equal to 2, and 10 over 5 also equal to 2. So yes, are in proportion. And of course, we don't need to mention the 90-degree. So it is sufficient to have these two ratios are equal. Okay, in the third case, we have also like side angle side. Okay, like side angle side. We have a side, but in a proportion. We have a hypotenuse R, H, S. Are right angled. Okay, so two sides. One of these two sides are the hypotenuses of the two triangles are in a proportion. Good. And the third one, angle side angle side, where the angle is included between the two matching sides. Okay. The two matching, no, the two corresponding sides, because they don't match in a similar triangle. They don't have the same size, the same length. Good. Normally, so it is sufficient to say that this angle equal to this angle included between these two corresponding sides, and it is sufficient to say the highest here, 15 over 5 equal to 3, and 9 over 3 equal to 3. So yes, they are in proportion, and the two included angles are equal. Good. And the remaining one is angle side. Angle side. So we have angle side. So it is not because we have only one pair of sides. So we can't compare to another ratio, to another scale. So we drop it. We drop it. So we don't mention it. So it is sufficient to say that the two angles only, two pairs of angles are equal from the two triangles in the two triangles. Why? Because of course, if two angles from here equal to two angles from here, the remaining, of course, naturally it's equal, because we know that the sum inside each triangle is equal to 180. So normally the remaining here equal, of course, the remaining of here. These are the tests, the four tests for similarity, and you can also assess yourself using by these the following exercises. They ask us, for example, here to state the used test for having similarity between these triangles. So normally we have three sides here. We don't have any shadow, any trace for angles, for values for angles. So normally we want to use we have to use the given sizes. It is clearly that 26 over 13, the longest here over the longest here equal to 3, equal to 2, sorry. The midest 22 over the midest here, so 22 over 11 equal to 2. Okay, we are in the same ratio until now. And 18 over 9 equal to 2. So normally, yes, we succeeded to justify that we have three pairs of sides of sides are in proportion. And here, for example, we have two angles sufficient for us. Why? Because we have 32, 32, 110, 110. So we have at least two pairs of angles are equal. So of course, as a result, this one is equal to this one. So normally, at least two pairs of angles are equal from both triangles. So these two triangles are similar. In this, we are working in a particular case with right angle triangle. So yes, we don't mention the 90-degree. It is sufficient to say that we have hypotenuse over hypotenuse equal to the side, other side over the other side, the given other side over the other. So 18 over 6 equal, normally equal to 3. And the 15 over 5 equal to 3, yes, or a pair of hypotenuses and a pair of sides are in the same proportion. In the same proportion, we say. Okay, good. And you can complete by yourself the following one. All the following are important. For example, they ask us in this example to state why the following pairs of triangles are not similar. So why they are not similar? Because we have only two pairs of sides are in proportion. How? Longest over longest. 8 over, for example, 8 over 15 or 15 over 8. 15 over 8, 15 over 8, and also the midest is 14. 14 over 7 is 2, but 15 over 8 it is not a 2, so different. So normally, and 12 over 6 it is equal to 2, so only we have two pairs of sides are in a proportion, the same proportion, so it is not sufficient to have a similarity between these triangles. And here, for example, yes, 16 over 8 equal to 2, 14 over 7 equal to 2, but the angle here is included, is not included. We have it away from the sides, the used sides. Okay, and these are the two right angle triangle. Hypotenuse over hypotenuse equal to 2, and the other side 11 over 5, not 2, it is 2 points. So normally the proportion of the second side of the triangle is not the same as the proportion of the hypotenuses of the triangle. So we should check all condition of test of any appropriate test to be satisfied. Okay, all these exercises are to assess what you have already understood from the explanation of this lecture. And you should know that it is very easy also if we have two similar triangles to find some unknowns, and especially as sides. Because if we have a similar triangles, so we should know that that's a side, the corresponding sides from both triangles are in the same proportion. So we can use one of these methods. For example, we can find the scale factor for first of all, and then use it with the other ratios to find the unknown side. Okay, or we can identify the pairs of corresponding sides and equate their ratios in the appropriate order. It is not a big issue. How to identify the pairs of corresponding? So normally we have this angle equal to this angle in the other triangle. The opposite of this angle is this side. So normally this side is corresponding to this side. And similarly, this angle equal to this angle. So the opposite to it, this one. So this side is in a proportion with this side, corresponding to this side, and so on. So it is easy to use it to find the scale factor for scale factor first of all, and to continue to find the unknown. So these are the important information of today. Thank you for listening. Have a nice day.